Okay, we are live as usual. Welcome to our second devlog for our project that we're working on, the NLP project, sentiment analysis. Very excited to be here, and thank you for joining us. Um, and let's just get right into it. We're going to be covering data and pre-processing, like data analysis and sort of the steps that we took. I don't need to zoom. And so for those who don't know or who are new to our meetings, thank you. Thank you for joining us. And what we normally do is we have this, it's called Deep Note. It's wonderful. It's a notebook, and we normally do it in here because then we can show you guys the actual outputs, and it's very interactive, and we can always send it later. So David, if you could put that in the chat, please. Just in case you can follow along on the screen, we'll be sharing it and doing it here. But if you'd like to see for yourself, that's also awesome. So we're starting off, we're importing pandas and NumPy. They're pretty regular libraries that almost everyone uses when we're handling data and so on. So that's for linear algebra. You have a lot of the math in NumPy, and then pandas. We had our pandas workshop if you'd like to check that out. And it's just for moving around data and working with it. So what data sets do we consider? Because with this NLP project, NLP takes a lot of data, and we need clean data. And a big one was a lot of people were using tweets. They extracted tweets and made into data sets. So we started looking into those. And so we have this one. We look for them on Kaggle. It's a site that makes it a lot easier because you can just download it and you can see the actual data and some things about it, if it has missing values and so on and so forth. This one has 17.2 thousand. So it's quite a lot, but when we're talking about NLP, we need even more for a good model, at least. But this one was not good. It's not balanced, and it doesn't even have the sentiment. So cross that one off our list. This one, we considered it. Maybe if we need more data, more, this is more about art and museums. So it's kind of like taking people's opinion about a certain museum and so on. But we didn't think it was too applicable. So we just put it to the side. And now the actual data sets that we're using are right here. If you'd like to check them out later, I'll go briefly into it. So I call this one the tweet 2, but it's sentiment analysis data set. And this is what we get. So it has 9 columns, and I'll put it like this so it's a bit easier to see. There are some missing data, so that's obviously something we need to take into account for. But other than that, we have our text ID, we have our actual text, the sentiment, which this is important, this is what we need. Time of tweet, age of user, country, population, land area, density. We don't really need that, it's cool, but for our purpose, we don't need it. So you can see here are some of the values. And the main ones that we're going to be using is the text. So what the actual tweet was about when it was extracted, and the sentiment, which they already labeled for us. So this is really good. Because for our project, we're planning to have user input. Somebody can put in a sentence and they'll get some kind of a sentiment percentage and what the model thinks it is. So that's really good. And I won't go all over. I won't go too deep into all of these. But this person, he put together quite a lot of data sets, but we're mainly using the test CV and train CV out of this cluster. And then we're also using the 1.6 million tweets that we are, actually, I'm gonna turn off the waiting room. So this is our 1.6 million data set. So this is definitely enough data for us to use just on its own already for now. But it's kind of, there was a lot that we needed to process, which I will talk about right now. So that's kind of the Kaggle stuff you guys like. So very good website. I recommend it. And what we did is DeepNote has this way that we can put our data here, so we can easily use it. So that's just, if you're wondering what this is a folder that holds what we named a Twitter 4 combine, which is the cluster data set, this one. And then our 1.6 tweets, which I call the Twitter million set. And that just holds our CSV, which CSV is just like an Excel file. If you think, you can think of it like that. It stands for comma separated values, but think of it like when you open Excel, you have all these values and they're kind of separated. It's just a way of organizing them. Now, we start off by first our million tweet sentiment CSV. And again, if there's any kind of questions, anything, feel free to interrupt, put it in the chat. We'll be more than glad to help. And so this is just our regular, we're using our path as a variable. And this we get from, again, this is just part of the DeepNote syntax, or how it's structured. And so what we did is we use our pandas function read CSV, where we're reading our path, and this is an F string. It just allows us to put a variable with some kind of string. So we have our path, which we defined right here, and we have our CSV, which is in that folder, right? So far, it's not that bad. This is just trying to get the CSV to be in our notebook so that we can play around with it. And don't worry too much about the encoding if you're confused about that. That's not too important. It's just an encoding. So now we're looking at, when we're using .head, we're looking at the actual data frame. So almost like the table. And we see it's kind of weird. Our column names are not good because this is actual values instead of names. This is really not good. So we know we're gonna have to deal with that. And we have all these values. So we have another way to look at some information about it. I just thought I would throw that in, but we have enough from just this table. So the first thing we have to do is, there's all these values that we actually don't need from the columns. So what we do need is, you guys don't really know this. Luckily, we get this from actually looking at our Kaggle, because there, for some reason, I think they messed up their naming. But here they have, that's the target, which is the polarity of the tweet. So you have 0 is negative, 2 is neutral, and 4 is positive. And that's just a choice that they made. And then you have all these other ones. So really all we're looking for is the target, because we want to know the sentiment of that sentence. And we're looking for the text, because we want to understand, okay, what, the sentiment is coming from which text, right? So yeah, so that's what we're doing. And what we're doing right here is we're actually just dropping all of the columns we don't need. So anything that's not the text and the sentiment, and this is just using .drop. Then we're checking our table again, checking how it looks like. It looks a lot more manageable now. We only have 2 columns, and we have our values, but still the title is not good so far. So what we need to do is we need to give it the column names. You see, we're changing the column names to label and tweet. So our label is our polarity, so our sentiment, and our tweet is the actual text that that we're associating to the label, right? So far, are we good? Any questions? Okay, I think that's good. Feel free to interrupt me if you think of anything. And if you're on YouTube, just comment it or tell us because I can't hear you there. But yes, so we are printing. We want to print out our column names just to check that everything we did is good. That we only have the label in the tweet, and we do. We have it right here in our output. Now, what are we doing right here? So I put this so that you guys would understand, but we have our original polarity labels was 0, 2, and 4. And we got this from the actual person who created the data set. And they're telling us, okay, so 0 is negative, 2 is neutral, which I put DNE, which stands for does not exist, because for whatever reason, they gave us a label, but they didn't actually have any data for neutral. So little mistake on their end, but for our purpose, it's still okay because we're just going to be focusing on the negative and positive, which in this case is 0 and 4. So no point in changing the neutral because there's just no data for it. So what we did is we got our data frame. We used lock so that we could say, okay, well, lock is going to return when we have a label, when label equals 0, you see when label equals 0, it's going to return the value, which is going to be like, it's going to be, wait, if this is negative, we have to look at it. I think negative is 0. So it's just going to make sure that negative is still 0. And then the same for our positive, but we want it to be 1. So this is just a personal choice that David and I preferred to do it because 0 to 4 doesn't seem very logical rather than more of a binary of 0 and 1. Does that make sense? Yeah, awesome. So now we have, we changed our column names. We changed our labels so that it's more fitting to what we wanted. And so we have our labels as 0 is negative and 1 is positive. That's our sentiment. So let's make sure that when we're doing this unique, we're saying, okay, well, we want to know in from this data frame, this from the label, tell us the unique values that there are, right? And so we're just checking again. Always got to check because when you're dealing with a lot of data, you want to make sure that what you did is right, and it's very important, especially because we're feeding this into a model. It's highly sensitive to any kind of mistakes, and you'll see about that when we explain later. And so we're just checking how it looks like. So I put it as raw output because it's kind of tiny, so you can still see well. But we could look at it like this. And we have our label, our tweet, and so far it looks a-okay. So good. We have that. Now, that data set is so far okay. So we're done with that one. Now we have our other data set. I don't know if you guys remember. What we just did is a Twitter million set that has a 1.6 million. And we also have the Twitter 4 combined. And from there, we're actually going to use the train. It has 2 CSVs that we're interested in, the train CSV and the test CSV. And those are going to be useful for when we do our model. We can train our model and then test it to see how good the model is and how accurate it is. So let's do the same that we just did, but for this step. And there are a bit of changes because whenever you're getting a lot of data sets and you're trying to merge them together or have one consistent basis for our data, you're going to have to change different things because people put them in different ways. And So you have to account for that, and that's why pandas is so useful. So this is our trained CSV, and I just put here for your information, holds 4 different CSVs. We're doing the same thing, except we're actually calling this data frame in a variable. We're calling it train df. And so we're reading the CSV, just like we did before. And now we actually have our thing. Let's check out how it looks. It looks a lot better than the other one. It actually has column names, which is really useful for what we're doing. It has column names. So far, the data looks good. The sentiment, they're actually turning in, they're saying the full sentiment. So they're saying neutral, negative, and positive. That's the 3 labels that they had, which we know just because we saw that the Kaggle and we analyzed the thing, but you can easily do that using Python, pandas, also Python, but Python in conjunction with pandas. And so we have our sentiments, which this is important. We know we want that. We don't really want the time of tweet, the age of users, the country, the population. We don't need any of this. So we already know in our mind, we're going to have to drop some columns. But we do want the text and we want the sentiment. Because what we're trying to do is we want to make it similar to our previous data frame. Put it in kind of a format. So let's check all the columns that we have. Okay, we have those columns. That's also easier when you're doing the code because you don't want to be looking and then scrolling and memorizing because you have to spell it correctly. So you can just take it from here. So we're dropping text ID, selected text, time of tweet, age of users, country, population, land area, and density. And we're all dropping all of these because we only want the text and the sentiment. Now, if you're wondering, what is this? Don't worry, it looks scary. It's pretty cool. It's actually how they did the squared. And so you can't really square it like you would in Word or something in the code. So that's just a little code that says, put this as a superscript. So now I'm printing the columns again, just to make sure that what we did was successful. And it was, because we have our text and we have our sentiment. So far so good. Now, we have our text and we have our sentiments, just like we just checked right here. Now we have it in a more visual form. And we can see how our data starts to look like. Okay, so we have a neutral and then negatives, which is always good if you have the first values because you can kind of gauge it easier to see, well, if I change neutral to something else, at least I know it's a bit different than negative. But anyways, so what do we need to do to this data to make it look like the other one? So we know we're going to have to remove the neutral values because we're not using neutral. Here they actually have neutral values, which would have been good, but we decided not to go with it and just go with negative and positive. So we know we're going to have to remove the neutral values. Then we're going to have to switch the order because if you guys remember, the label is actually on the left. See, left, and then the tweet is on the right. So we're going to have to flip those right here. We're going to have to flip those so that the sentiment is actually on the left. Then we're going to have to change the labels, which by labels we mean the sentiment. So the negative, the positive. So we're going to have to change those because we want them in 0 and 1. So 0 for negative and 1 for positive. That's what we chose. It also kind of makes sense because, binary on and off. But so that's what we did. And then, of course, the column names, because that still matters. Even though they're similar in value and everything seems to pan out, we need to make sure that if we have one data frame that has label and value. Is that what we use? Label and make sure. No, label and tweet because it's actual text. So if we have label and tweet, we need to make sure that we also have label and tweet. Same names, so they're compatible. So what we're doing is we're just the same variable, just so that we don't have to mess with our memory. We're using the same variable, and what we're doing right here is we're actually removing the neutral values. And if you're wondering how this works, we're saying in this data frame, um, I want this data frame that we're calling the variable. I want it to be the same data frame that we just did, but only the values where in sentiments. I hope you're following so far. Sometimes it gets confusing. Trust me, I still get confused all the time. So in this data frame, in sentiment, we want the values that are not, so is not, this is the operator for is not, neutral. So we want everything but neutral. And it's that easy. We got rid of them. Poor neutral. It was a good value, but not to us. And we're printing our, again, using unique, we're trying to figure out, okay, in the sentiments, we need, what are the unique values? Just to make sure that we got rid of neutral. And we did. I just thought of a pun, like neutralizing neutral. Never mind that. It was awful, but I had to mention it because it would just mess me up. And so then what we're doing was we're just checking out how it looks like. So that was really disappointing. But yeah, so we're checking in our data frame how it looks like. And we have our text, we have our sentiment. Okay. All we did so far is remove the neutral values. Still have quite a bit to do. Actually, it's not that bad, but still. So now we need to switch the column order so that we have the label on the left and the text on the right to fit the other data frame. And so we do that by just doing this. It's very simple. There was this, I was surprised of this answer because it's a lot more simple than what a lot of people do, which is like turning it into a list and then using list comprehension. But don't worry about that. This is just how we can do it. To switch the column order. Now we have our sentiment on the left and our text on the right. Still looking different than our the shadow rest. Hey, I wouldn't have even known how to do either one. So they're way ahead of me. But yeah, so it's still looking quite different than our data frame. So we still have a bit to do. What we're doing is, this might look familiar. This is almost exactly how we did with the other one, but this time is specific to our data frame. Again, we're locating this value, so we're looking for the negative values and changing it to 0. So instead of having the actual word negative and positive, we want to put numbers in. So that should be good. And in fact, just so you guys can see it, hopefully this works. We can get some values to see that it changed. Okay, the reason that's a deep note.
You can't run it again.
I can't?
Yeah, bro. Sentiment isn't there anymore, bro.
Yeah, I know. If I restart the thing, it'll work. Don't worry. It's a deep note thing. But there we go. We have our sentiment. This is our negative and our positive. So luckily we have a positive value here, so we can kind of visually see it and not really have to check too deeply into it. So that works. And what we're missing still is our sentiment and text, our titles. So we do just like with the other one. This is almost the same exact code actually. To change your column names to label and tweet. So we can change this to label and tweet. And in the meantime, we're also resetting the index because you guys didn't see it because we already ran this, but before it started on 1. And we want both to start on the same index, which in the other one is 0, which is actually the natural index. So it starts off on 0. That's what we're doing right here. if you're wondering. And if you guys didn't know what in place is, it just means that um, that actual data frame gets changed. So you don't have to put a new variable. You can actually just change the whole thing, which can be dangerous, but it's good in our case.
Yeah, so those functions like reset, index, or like rename or drop, they return the data frame with the changes made to them. But with the in place equals true, you can make it so that the effects go directly to the data frame itself and so it doesn't return like another data frame.
Mhm. Perfect. You heard it from David. And yeah, that's exactly how it works. So thanks, David, for that. It's really good. Yeah, so now we have our data frame. Looks just like our other one, actually. Just the data is different. And if you're looking at this data, it's questionable at times. It's interesting what people tweet about feeding the baby. I actually looked at this whole value. It's pretty interesting. But anyways, this is our tweets and our labels. And that's all that we have to do so far for a data analysis. We're just making the data frames into something that we can actually use that are uniform. Because remember, when we're dealing with data, we want it to be uniform and kind of predictable, actually. Maybe not the values, but you want everything to be well organized. And yeah, I will stop sharing so that David can take over the next part. And if you have any questions, just ask.
Okay. So any questions so far before I continue? Maybe just let me know if there are any in the chat. All right. So we did a little bit of messing around with our data. We created 2 data frames. We forgot to actually concatenate them. We can do that live. But for now, let's compare the first 5 values of both data frames. And here we have here. Yeah. So as you can see, we have the same labels and we have our tweets. And you can notice right here that there's a couple of capital letters. And I don't quite like having capital letters because when you train a model, the capital letters do matter because fun with a lowercase f and fun with a capital case F to an AI are not the same. It's not the same word. So I made this function here, lowercase, where we limit the text, and it converts it to lowercase. And I just applied that to the tweet column of train df, but I didn't for million tweets. Million Twitter, is that the name of the data frame, Hermes?
Not the one that you want to use. I think the one you want to use is train df. That's the one that's split already. You can use.
No, yeah, but we already did that on the. I already lowered it on the.
Yeah, it's million Twitter for that one for 1.6.
Some live coding for y'all. I'm gonna apply. So it's gonna feed in every row of the column. It's gonna apply the lowercase function to the row.
Don't forget capital C for the function. It's capital.
Oops. Best practice. Let's make sure those changes happen on both of them. Yeah, so looks like the changes took effect. This is for train DF. Yep. All right. And we should probably concatenate them as well. Is it PD concat? Let's see if this works. Object type. Was it concat or merge?
It would have been concat. If it was live coding.
You know, it is what it is. While Hermes is looking for that, let me explain how we're going to be using this data. So for the actual classification of the sentences for either negative or positive, we're going to be using BERT, which stands for bidirectional encoder representations from transformers. So how does BERT work? BERT makes use of transformers, which is an attention mechanism that learns contextual relations between words or subwords in a text. Usually, transformers would have an encoder for the input and a decoder for the output task, but BERT only needs an input because its goal is to create a language model. Unlike LSTM models, the transformer models read the entire sequence of words at once. So let me try to show. For an LSTM model, you would put in the words one by one. And that's why you can use it for word prediction, because you can have the model learn, okay, this is the order of the words. This is the order that the words go in one by one, and just predict the next couple few. But with a BERT model, it actually takes in entire sentences because it's a transformer. And the reason it's called bidirectional is because when the model takes in the entire sentence, it actually has the beginning and the end already. So it can go either forward from left to right or backwards from right to left. And that's why it's so good at doing all these NLP tasks. So how do we use BERT for sentiment analysis? So classification tasks such as sentiment analysis are done similar to next sentence classification. It's done by adding a classification layer on top of the transformer output for the CLS tool. And I'll talk about that right now. So here is a sample, a picture of what the BERT model looks like. So up here you have your input. My dog is cute. He likes to play, or playing. He likes playing. So here we have a CLS. This token right here basically marks the beginning of the sentence. And this separator and this separator basically marks the end of the sentence. Or from what it looks like, it also does punctuation as well. And when it goes into the model, it gets embedded. And then it embeds itself into a sentence. And then it gets the actual positional embedding. And when we actually going to like classify, like, oh, what's going to come next or what's the sentiment, we actually need to put in another layer to this, a classification layer here to get these transformer positional embeddings and and well, classify it into whatever you want. And for us, it's going to be a binary classification of either negative or positive. So how do we get BERT? We're going to use the Hugging Face interface, which is a very good collection of models, data sets. And for our models, we're going to be using the BERT base uncased. It's a very seamless design of this website. It's very good. I would recommend Hugging Face if you're into NLP. So we're going to get our BERT tokenizer, which is going to do all these token embeddings. And we're going to get TF-BERT for sequence classifications, which is going to be our model. And we're going to get an example of input features. This is going to just be for, well, we don't really need this for now. That's just to test our input into the model, but we don't need it now. So for our model, we're going to initialize it for TF-BERT sequence classification class, and we're going to get a pre-trained model. We don't really have that much data, so we're not going to train the transformer with our data. So we're going to get an already trained model, an already trained transformer model, and we're going to get a tokenizer for a tokenizer, and we're going to get a pre-trained tokenizer as well. The one thing we can train, though, is our classification. So as you can see here in the model summary, we have our BERT. This is going to be the token embedding, the positional embedding, all that. A dropout layer just to prevent correlations between BERT and the classifier. And as I mentioned before, the classifier is just a neural network. And we can actually specifically train this dense layer with our data so that it produces better results. And that's what we're going to do. Any questions? Oh, Hermes, did you find
It's a pain. I mean, this might work with concat.
Concat is not defined.
Yeah, sorry, it's
Oh, look at it. Let me see.
nah, it did it by row, but axis one's supposed to be column.
Oh,
wait,
maybe put them right next to each other. Put axis 0.
Yeah.
All right, let me see.
That might work.
Train shape.
Joining data frames can be difficult sometimes. It worked? Yeah. Okay. It's reassuring.
Wait, did you run it? Did you run a notebook?
I mean, like the actual cell, yeah.
Oh. All right, let's try it out. Let's see. I'm pretty sure that's
yeah.
It's money, right?
Yeah. It did.
Let me make sure.
Because it looks weird because it's 99,999. Like it has a bunch of nice, but it's exactly the same one. Because if you look 63, you take one from 63, it's 62.
All right, yeah.
Okay, it worked. Like coding can be stressful sometimes, but we got that to work. And yeah, I mean, is there any questions for any of us? Anything about BERT? Fun fact: BERT is it's based on Sesame Street. the character BERT. Obviously, it stands for bidirectional encoder in mode. Okay, so David, we have a question from Lazarus. What are the next steps for this project? Interesting question. So feel free to join in, David, if you want to. But
so what are the next steps? Well, we're gonna try to get this model up and running, and we'll try to train it, the classifier, as we mentioned, with our data, the Twitter data, so that it can actually know, okay, this is positive and this is negative for these tweets. And from there, after that, if we get some good accuracy, we're gonna have to actually pre-process the test data set that Hermes mentioned before, because one of the data sets was split into train and test. We're gonna pre-process the test data set, use that as our validation and our test set. Hopefully get a good accuracy with that. And then from there, we're going to actually go into a little bit of web dev. We're going to use Flask to deploy our data, on a website. So it's gonna be a website that's gonna have like an input cell where you like put in a sentence or whatever. You press a button and the website will tell you, oh, this is positive or negative in terms of sentiment.
We're going to try to get a really good design, because we don't want to give you a project that looks bad. I mean, granted, you guys can always fix it, but David and I think we got some designs in mind, make it look really nice and user friendly. And yeah, in our 4th devlog, which is in 2 weeks, if I'm not wrong, you guys should be able to go home and use your project and fix it however you want. So.
Also, to get this notebook, I'm pretty sure there's like a duplicate button on like the top right. You can get it, and you can modify it however you want. Make it your own.
Good. Yeah, because we also we are cleaning up the GitHub repo for us, like for all the things that we've done, to organize it really well so that you guys can just pull it, use it for yourself, work on any of the projects, and really have a nice place to have it really organized. So this will be on it. And yeah,
all right, any other questions before we end the meeting? We have 5 minutes left.
I'll pause the recording in the meantime.